All right, so this is a review of area of a triangle using matrices, Cramer's rule, and the inverse matrix method. So you have these points here. A would be 3, 5, B, 8, 1, and C, 5, -2. So this would form a triangle, but you don't really need to draw the triangle because with matrices, it doesn't matter the way the triangle is formatted. So in the matrix, it's 1/2 because in the area of a triangle, 1/2 base times height. So the first x coordinate, which is 3, goes x1, y1 is 5. The second x coordinate for B, x2, and then the second y coordinate, which is for B, is y2 here. And then C would represent x3, so 5 is x3, -2 is y3. And to make it a 3x3 matrix, because you have to have a square in the matrix, you have to put a 1, 1, 1 because 1 doesn't change what the values are. So now when we plug the numbers into all these places, let me just erase this first. So you have the 3, the 5, the 8, and the 1, 5, and then the -2. Sorry about that, -2. And then you want to expand this to make for the 3x3. So 3, 5, 8, 1, 5, -2. Then you do the diagonal. So from here to there is 3. And then this diagonal, 25. And this diagonal is -16. And when you do this math, 28 minus 16 is 12. And then now you do the top. So now it's 5 times 1 times 1, which is just 5. -2 times 1 times 3, -6. 5 times 8 times 1 is 40. 40 minus 6. 5 minus 6 is -1 plus 40 is 39. And then you do bottom minus top, 12 minus 39, which gets you -27 as the determinant. Now you can, now with the triangle, you do 1/2 times -27, 1/2 of that determinant, which is -13.5, but this was an absolute value because you can't have a negative area. So the real area would be absolute value, which is 13.5. All right, so now we're going to move on to Cramer's rule here. Just finished erasing that. All right, we're ready for Cramer's rule.
Okay, so first we're going to write down the system of equations we have. This is going to be a 3x3 systems of equations with 3 variables and 3 equations. So let me just write this down. Okay, so first we're going to set up the matrices to get the determinant of this equation or the system of equations. So we're going to have x, y, z, like the coefficients for each of these. We're going to put those in the matrix. So it's going to be 2, 1, -3, and we're going to ignore the answers for now for the first one. And then the second one's going to be 1, -3, 2, 3, 1, -1. And make sure your variables are lined up, so it's all the same variables. So it's z, 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 y, 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 x, x, x on top of each other. And then from there, we're going to have to repeat the first two rows, these two. Okay. And this is just so we can find the determinant. And same as before, we're going to have to take 3 diagonals both ways to get the determinant of the top and bottom. So first we're going to have 2 times -3 times -1, which is 6. And then 1 times 2 times 3, which is also 6. And then -3 times 1 times 1, which is -3. So you add those 3 up, and you get 9. And that's for the bottom. And then for the top, we're going the opposite direction. So 3 times -3 times -3 is 27. 1 times 2 times 2 is 4. And 1 times 1 times -1 is -1. So, and this has up to be 30. So we take the bottom, the number we got on the bottom, subtract that from the number we got on the top, or so we take the bottom and then subtract the number we got on top. And that's going to be -21. Okay. And now we have to find, so this is actually the determinant of the systems of equation. And from here, we have to find the determinant for each variable. So I'm going to erase all this and keep the determinant there. So now we're going to have to redraw the matrix, but instead of putting the coefficient for x, we're going to have to put the answer. So it would be 1, -3, 4 instead of 2, 1, 3. And this is because we're trying to find the determinant for x. Okay, and then we're going to have to do the same thing, repeat the first 2 rows. Okay, and then we're going to have to multiply again. So that's 4 times -3 times -3. That's 36. 1 times 2 times 1, 2. -1 times -3 times 1 is 3. And then going the other way, 1 times -3 times -1 is 3. 1 times 2 times 4 is 8. -3 times -3 times 1 is 9. So you add these up, that's 20. And that is 41. So then you take the bottom, 20, subtract it from the top, 41. And that leaves you with -21. So I'm going to write that on the bottom here. The determinant of x is -21. All right. Now we're going to do the same thing, but instead of putting the answers in for x, we're going to put them in for y. So we're going to find the determinant of y. So using the same system of equations, now we actually put the coefficients back in for x, but then for y, we put the answers. So if I want to label this would be x answers, and then z. So for z, it would be -3 to -1. So whatever variable you substitute in for the answers, that's the determinant you're finding, which, yeah, is y in this case. So then we have to repeat the first 2 rows again. Okay. And once again, we have to find the determinant. So 2 times -1 times -3, 6. 1 times 2 times 3 is 6. -3 times 1 times 4 is -12. So you add those up, you get 0. Okay. Then going the other way, hold on. Going the other way, 3 times -3 times -3. That's 9 times 3, 27. Okay. And then 4 times 2 times 2. 4 times 4 is 16. And then -1 times 1 times 1, which is -1. So here we have 27 plus 16 minus 1, which is 42. Okay. So then you take the bottom, subtract it from the top, and you get negative 42. So we're going to write down here, determinant of y equals negative 42. Okay. And now we're going to do the same thing for z. So it's going to be x, y, answers. So 2, 1, 3, 1, negative 3, 1. And then for the answers, 1, negative 3, 4. And then repeat the first two rows. And now we multiply. So 2 times negative 3 times 4, 8 times negative 3, negative 24. 1 times negative 3 times 3 is negative 9. 1 times 1 times 1 is 1. Here. So now we're going the other way. 3 times negative 3 times 1, negative 9. 1 times negative 3 times 2, negative 6. 4 times 1 times 1 is 4. So on the top, we get negative 11. And then on the bottom, we get negative 32. So negative 32 minus negative 11. So we have two negatives, so we make that a positive. And then negative 32 plus 11 is negative 21. So then we have the determinant of z is negative 21. So now we're done with the matrices part. And we're just simply solving for the three variables now. So to get the determinant, or to get x, you take the determinant of x divided by the determinant. X equals. So in this case, negative 21 over negative 21, x equals 1. And then for y, you do the same thing, but for the determinant of y. So you get negative 42 over negative 21 equals 2, y equals 2. And then for z, you use the determinant of z. And you get z equals 1. And that's basically it. You have your three answers there. So this is Cramer's 3x3. I'm going to have to erase this now.
Okay, so now the last thing we're going to do is the inverse matrix method, which is another way to solve a matrix. So if we write another system here, 2x plus 3y equals 10. And then x minus 4y equals negative 6. So now with this, you switch. Let me draw it out. So you do 2, 3, 1, negative 4. So now when you do it, you switch these two, this one and this one, and you negate these two. These are negated. So it becomes negative 4. And then over here would be negative 1, negative 3, and then this would be 2 now. Now you do the same thing to get the determinant. So cross multiply, negative 8 on the bottom, and 3 on top. And again, bottom minus top, negative 8 minus 3 equals negative 11. So now we put all of these over negative 11. And one more over negative 11. And then we can clean this up. We'll write a new one. 4 over 11, 1 over 11, 3 over 11, and negative 2/11. And this is times the answers up here. So we have 10 and negative 6. So now it's this one here times this first. So it's 40 over 11 and then minus 18 over 11. Which equals 22 over 11. And this now, because it's row 1 times column 1, this would be your x, which would be 2. And then you do the same thing for row 2 here. So it would be 1/11 times 10, which equals 10 over 11th. And then you do, oh, I'm sorry, this is a negative 1 here. And then you do 1 times 10 over 11, which is 10 over 11th. And then, oh, wait, sorry, this is a positive, my bad again. And then it's 10 over 11, and then minus 2 times negative 6 would be plus 12 over 11, which equals 22 over 11 again. Now, because it was row 2 times column 1, it would be on the bottom. So this is y when you make the matrix here, which equals 2. And obviously, you want to plug it back in to make sure your answers are good and everything's lined up.